In this video, we're going to learn how to model with absolute value equations and inequalities. So here's the first problem. The ideal wheel diameter for your car is 24 inches. However, the tire diameter may vary up to 7 inches and still fit your car. Set up an absolute value equation to model the maximum and minimum tire diameters that will fit on your car. Okay, so at the maximum and minimum tire diameters, the variation of the actual diameter with the ideal diameter is equal to the maximum variation, which is 7 inches. So now we just have to figure out how to express this variation in mathematical terms. So why don't we work that out on the side here? What does variation mean mathematically? Why don't we, just for the sake of argument, suppose we had a tire with diameter 26 inches, and then we wanted to find the variation between 24 and 26. In that case, we already know that the variation should be 2, so we can set up an equation that 26 minus 24 equals 2. So that's suggesting that variation takes the form actual diameter minus ideal diameter. Because 26 here we're interpreting as the actual diameter, and 24 is, of course, the ideal diameter. Okay, so let's do another experiment. How about the variation between the ideal diameter is still 24, but let's make the actual diameter, how about 22? What if we do the same thing, actual diameter minus ideal diameter? So actual diameter is 22, so take 22 and then minus 24, ideal. Let's label that actual minus ideal. What would that be? Well, 22 minus 24 is negative 2. But there's an issue in that we always want variation to be positive. So a way we can do that is we can put absolute value around this. Absolute value of negative 2 is equal to positive 2. And absolute value of positive 2 is still equal to positive 2. So it doesn't mess up anything from before, it just corrects this negative into a positive. So that's what we have to do here. Put absolute value around the expression actual diameter minus ideal diameter. That's equal to 7. Okay, so now we can fill in what we know. We know that the ideal diameter is 24 inches, of course, so put that in for the ideal diameter. And why don't we let d be the actual diameter? So then we have d minus 24, the absolute value of that is equal to 7. And then the solutions of this equation would then be the maximum and minimum tire diameters that would fit on your car. Here's another problem. The scores in a test ranged between 62 and 94. Set up an absolute value inequality to model the range of scores. So again, our starting point is with variation. And the full range of scores would be modeled by the scores which have variation less than or equal to the maximum variation. Now, before we get too deep into the inequality here, let's just set up a diagram so that we can intuitively understand what's going on here. So the scores on a test ranged between 62 and 94. That means 94 was the highest score, 94, and then 62 was the lowest score. And all of the other scores are somewhere in between 94 and 62. Now, say we have some point here. Say we have some score right over here. Say, for example, that score is an 80. What is the variation of this score? The variation has to be relative to some other quantity, so what is that other quantity? Well, it's just going to be the center of the score range. It'll be right in the middle there. And how can we calculate that middle? Well, we can just take the average of the two endpoints. So that middle point there is just the average of 94 and 62, which is just 94 plus 62 over 2. We can compute that. 94 plus 62, well, 90 plus 60 is 150, and then 4 plus 2 is 6, so 156 over 2. And then 156 over 2 is just 78. So this score here is 78. And now the variation between 80 and 78 we can compute by doing 80 minus 78, which comes out to 2. So it looks like we should take our score and then subtract 78, and there's our variation. But hold on, what if we take a score that's lower than 78? How about something like 70? What's the variation there? Well, according to this rule, if we do 70 minus 78, then we'll get a negative result, negative 8. But that's not what we want from variation. We want the variation to always be the positive difference. So how we correct that is we put absolute value around here. Absolute value of negative 8 corrects that to positive 8. And absolute value of positive 2 doesn't change anything, so it doesn't mess up anything that we determined previously. So there we go. There's our variation formula. The variation here, if we have a score S, say, would just be the absolute value of S minus 78. And that's less than or equal to the max variation. Now, what's the max variation? Well, we can compute it one of two ways. We can either do the highest score minus the center score. So we could do 94 minus 78. Absolute value of that is equal to absolute value. 94 minus 78 is just 16. So absolute value of 16, which comes out to 16. Okay, but what if we use the lowest one? Well, we'll just get the same result. If we did absolute value of 62 minus 78, well, 62 minus 78 is equal to negative 16, and if we take the absolute value of that, we still get 16, positive 16. So it doesn't really matter which one we do. Either way, we see that the max variation is equal to 16. So there we go. There's our absolute value inequality that models the range of scores. Its solutions are all those numbers in between 62 and 94. Now we know how to model with absolute value equations and inequalities, and in the future we'll learn how to use other functions for modeling purposes as well, such as quadratic functions.